and we're going to pick up a new kind of graph called a box plot, sometimes called a box and whisker. I call it a cat face. You'll see why I call it a cat face in a second. You guys have cats, you know what I'm talking about. What it is it's a graphical display. It's a graphical display of the 5-number summary with a nod to Alicia's 50% in the middle. That's why I love it so much. It gives you a couple different dimensions of the data. It's not a histogram. It's very, very, very different from a histogram. Although there is some intersection in what they both show you. I want to kind of bring that in today too as we go through today. So first off, how do you start? Well, you start by putting a scale down. I usually do them horizontally. You can do them vertically. I tend to default to horizontal if I can because we kind of read left to right more than down or up to down. And you need a logical scale for your data. Now it's been 5 days. You've had a long weekend where you survived gale force winds. What the hell was this data we were looking at? Do you remember? Number of states we visited. Woo! I know. That's okay. Number of states we had visited. So the first thing you want to do is you want to slap down a set of axes to build this thing off of. What's a logical minimum value to put on your graph?
5.
Oh, good. Can I go to 0? Is that okay with you guys? If you don't mind going to 5 is the minimum of our data. But if you're tracking number of states, 0 is the minimum, right? So I tend to give it wiggle room on both sides. Well, how about the max? Granted, 41 was our max, but because this actually nods to Faith and Scott's question, right? We can actually get some. Go ahead, Faith.
I almost don't even like 0 because
you've been in a state.
Yeah, you've been in.
So if you will nod to the artisticness of the graph, if you give it 0, you know we're going to be to the right of that, and it's going to fit better on the axes.
Okay.
Is that fair?
Yeah.
Good. And chances are, very few people have been to all 50.
Right.
As a matter of fact, I've never had anybody in the room who's been to 49, 48, definitely 41, mid-40s. Nobody's ever been all the way to 50 either. So we get this nice little cushion on both sides. Cool? All right. And then divide up the axis into regions. About 25 here. We go by 5s if you guys want. 10, 15, 20, 30. That's ish. I got a little bit cramped on the 35 there, but you get the point. That's bothering me. I gotta fix it. That's bothering the hell out of me. It needs to be the same width, right? Otherwise, you're going to skew your data. Oh God, it'll be worse. I'm going to pretend that's okay. Okay, first thing you do, you put little tiny tag marks at your min and your max, which in our case were 5 and 41. So you come out here, I want to make it a different color. Let's make it a green. Little tag mark on the min, 41, little tag mark on the max. Please, Dave.
Is there a y-axis?
No. These things just float above. Now, once we slap in a dot plot, which we'll get to in a minute, there is an implied y-axis. And the TI will give us one wherever it decides it. Very good question. There is no y-axis. It's still just one-dimensional data, number of states you've been to. But what's happening is we're not grouping them into a frequency anymore. We're simply dropping them horizontally. It'll pop. Good, very good question. Very good question. So make it as high or as low as you want it to be. Awesome. Now, bigger tag marks for the Q1, Q2, and Q3. So what we're going to do is, I forget what they are now. 10, 13, and 21. 10, 13, 21. How much bigger is up to you? How much bigger is up to you, honestly?
But those 3 need to be around the same size.
They should be, yeah. Yeah, just by convention, honestly, Faith, great question, by the way. You can make the median bigger if you want, but by convention, they're generally rectangular.
Okay.
Otherwise, they start to.
Yeah, so you wouldn't want it to be
No, because what you want then, you got the space, what you want to do then is do this. That's your box. Alicia, there's your middle 50%.
Okay.
There's your middle 50%. That's the box part of the box and whisker. And guess where the whiskers are going to be? Yes! You got it, Haley! The whiskers are the ones that come out like that. This is why I call it a cat face. If you kind of measure a little nose on the median, well, it would be a lopsided cat face, but it's a cat looking at you, minus if it didn't have eyes, or mouth, or nose. And it had two whiskers, so it's nothing like a cat at all, honestly. That is a box plot or a box and whisker. Now, why would I like seeing that versus just seeing the 5-number summary? I know it's visual, but what pops out of that that you don't get with a laundry list of numbers like we had, y'all?
The median?
But we see that in the 5-number summary, don't we?
Yeah.
Not as
Not as what? Go with that, girl.
not as obvious for me.
Okay, I like that. I like that, and that's good. That's good. It's not as obvious now. It's visual. It pops. We know it's in the middle of the. Well, I say middle. It's within the middle 50%.
Well, the middle 50% pops out.
It's good. The middle 50%. Alicia's middle 50% pops out. This distance right here, just so you know, the distance between Q3 and Q1 actually has a name. It's called the interquartile range. It's discussed often in statistics. The interquartile range. So for us, that would be what, 11 states? 11 states. 50 of us have been to that number of states, right? Between 21 and 10. So just so you know, it's also called an IQR for acronymicalness. Whew, get up words today. So good. Why else, Joanne?
So does it show the range of how far things are going to be from the main core group?
That's what you pick up versus just having a laundry list of 5 numbers over there. Remember how I said, yeah, if a cat had different length whiskers and its nose wasn't in the middle of its face? You see what the median is? I love it when you guys say it's the middle of the data, because it is, right? But middle doesn't mean center. You see where this median is? Hey, check this out. The median's 13, right? How much distance is there between the median and the minimum?
3.
8, right?
Oh, I thought you meant
3 to Q1. 3 to Q1, 8 down to Q0. So 8 states. How about from the median up to the max? 31 states, right up to the max. We got some you see the skew. Way more here than you do with just a laundry list of numbers.
So 8.
You see what I'm getting at here, friends? You're starting to see, hey, let's do one better. Let's do one better. I'm going to add a dot plot to this graph. Is that okay with you guys? No. I'm going to come in here. Davidson, I love what you said about the y-axis and it not having one. I'm going to kind of force one by dropping a dot plot in here. Joanne, go ahead.
Well, and then that supports the whole, it's not a bell curve.
It sure does. When you draw a box plot and it looks this leany, you can not even have to look at the data and realize it's most likely not going to be a bell curve. It's got too much tail on this side and too much clump on this side. What I love to see personally is both together. That's my personal opinion. Now here's something Excel nor your TI can do, but we can do it manually. What I'm going to do is I'm going to wheel this thing over a little bit closer. Actually, I'm going to grab the raw data list, and I'm going to go ahead and put a dot plot on this axis down here. Now we're going to show you how to approximate that in your TI in a minute. But watch this. 5, 6, 7, 8, 9. I got 5. I got 6. I got a 7. I got an 8. I got a 9. I got 3 10s. I'm developing your y-axis for you, Davidson, right here. Without actually putting a y-axis down, I'm giving you a y-axis by trying to uniformly space the dots. Yes, sir, yes, sir, yes, sir. I got an 11, I got 2 11s, 2 13s. I got a 14, I got a 14 and 3 16s. 18, 21, 22, 23. Fun noises. 25, 27, 41. Uh-huh. Now, when you look at that, you look at that, you see clumping, yeah? You get clumping. You see why this is so narrow and this is comparatively so wide. What percent of the data is in here? Be brave, be brave. 25%. What percent of the data is in here?
25.
What percent of the data is in here?
25.
What percent of that? I like the song back there.
25.
25. It's a quarter, a quarter, a quarter, and a quarter. That means there's the same number of data points in every one of those ranges, yes? So why do they look so vastly different? Because the ones on the left have very little variation, and the ones on the right have tons of it. That's why I love the box plot so much. Even better when you pair it with a histogram. Even better. Even better when paired with the histogram, because then you can actually see the shape of the distribution on top of the spread. So Joanne's, I love it though. Just looking at the box plot by itself, you can go, we got some skew issues. Yes! So even without having X bar and S in front of you, you can start to suspect it. Now, what some statisticians have started doing, they've started adding the average to the median. I've seen this happen, where our median was 13, and I think our average was 15. They've actually come up and put like another symbol on the box plot to show where the average is. I kind of like that. I kind of like that because the further it gets from the median, the even more skewed it starts to look. If that's fair. Yeah. But if that thing is not balanced left, if it doesn't look like a normal cat's face looking at you with the same size whiskers on both sides and the same rough size cheeks or whatever these things are called on a cat, you know you got some skew. It won't be perfect because data is not perfect. But when it's that extravagantly extreme, that's when things really start looking interesting. Scotty, go.
So, for like experimental purposes,
yes,
control groups have to remain in the 95% of the data or the 80% of the data. Is that correct?
What type of error do you want to avoid more? A type 1 or a type 2? False positive, false negative?
False negative.
Then 95% is not the measurement to use.
Okay.
Scott's asking a very good question, one that I want to get at by the end of this course. I always resist saying this because Taryn's going to jump on my throat and be like, why do you keep saying that? Here's the deal. There's two ways to be wrong in a statistical study. You can have a false positive or a false negative. Your last project is entirely devoted to false positives and false negatives. If you're taking a disease test, which one is worse, a false positive or a false negative? FYI, a false positive is when you take a test for a disease and it comes back positive, but you're actually healthy, you don't have the disease. That's a false positive. A false negative means you go take a test for the disease, it comes back negative, but you actually have it, but it says you don't. So what's worse? That's a loaded question. That's a loaded question. You can't answer that without context. If you are being tested for, say, a grave disease, I'd rather err on the side of a false positive, right? I'd err on the side of a false positive. But if you're taking a test for, say, I can't think of something off the top of my head right now. I had Lyme disease 3 times. I tested negative all 3 times, even though I had it 3 times. And I got the rings and everything. It was a terrible test.
HIV.
Right, HIV, you got a whole project devoted to this. The reason I bring this up is the 95% is based on the assumption that you're willing to accept no more than a 5% false positive rate. The trick is that ignores the false negative rate. And 244, I promise you 244, we're talking about it right now, is how to balance those two things. Which way would you rather be wrong? As a rock climber, for example, if I'm hanging back in a harness, thousands of feet off the deck, hooked to a rock with double redundancy, I don't want that little gear loop to pop and have me fall backwards. So I'd rather them recall the harness and be like, I just want to check that again. How many of you guys have had a vehicle recall? For your car? Yeah? When they recall your car, do they find something wrong with it all the time? No, very often there's nothing wrong with it. But they want to alleviate the chance of that, of missing the problem. That's why I want to bring my harness in once a year and have them check it. If they would do this. Nobody actually does this. But if they would, I would be down for it. Because the last thing I want them to go is, that harness is great, dude, go ahead. Yeah, but it's, no, it's good. Boom! That's the last thing I want to have happen, right?
But if you wear it the 5th time, you're screwed.
Well, and that's what we get into in 244 is studying how many times until. How many times until, right? So, Scotty, it's a loaded question.
Okay.
That's a long-winded answer. Just say it's a loaded question.
This goes with chi-square, essentially, right?
Well, that's a subset of all of this
It's
analysis,
basically
yes.
saying what your error rate could be.
Yes, but even that depends a priori. Before you do the experiment, you have to decide which way you'd rather be wrong.
Okay.
Fair?
No, that's
Good, good.
appreciate that.
Now, You guys still have the data in your TIs, yes? Yes? If you don't, pair up with somebody that does. Because what I want to show you before break is, I want to show you how to generally generate both of those curves in your machines. Okay? Generally generate. That was kind of fun to say, actually.